In the previous example, we learned how to do the nth derivative in a calculator. This means that we can now take the derivative at a point without having to do a bunch of computations. However, in this example, we're going to look at when this nth derivative fails. So using the calculator, we're going to compute the derivative of the absolute value of x when x is equal to 0. So we push math 8, so d dx, and then in here to get the absolute value function, you push alpha f2, and then absolute value pops up. So now in here we put x, and then at x equals 0 and push enter. So this tells me that the derivative is 0. So then the answer is 0. However, we've seen in previous problems that the derivative of the absolute value of x does not equal 0. So your calculator doesn't recognize where the derivative does not exist. What we need to do is to look at the graph. So if I go back to my calculator and I go ahead and graph the absolute value of x, so again it's alpha f2 and then absolute value, and then push in x and hit graph. Remember, my window might be messed up, so in order to fix your window, you push zoom 6, and that's going to give you the standard 10 by 10 window. And so I'm going to zoom into 0 a little bit. And so you can see at x equals 0, we have a corner. So therefore, the derivative does not exist here. So this is dne. On your own, I want you to determine f prime of 0 when f of x is equal to x to the 6/7 power. All right, let's give it a try. A shortcut to doing the nth derivative is alpha f2, and then the third option down is the nth derivative. And then I want x to the 6/7, so x to the power of 6 divided by 7. When x is equal to 0. And so this actually gives me 0. So then this is equal to 0. However, we always have to check our graph before you believe your calculator. So let's actually graph this function now. So when we graph this function, it looks like it would be okay. So this actually makes what we call a cusp. And if I zoom out, it makes it actually easier to see that cusp. And so what I did here is I changed my window a couple times so that way we can see the graph and try to see that cusp a little bit better. In example 4, we're going to look at how to graph the derivative of a function with using just your calculator. So we want to graph f prime of x if f of x is equal to ln of x. So I'm going to show you first how to set it up, and then we'll do it on the calculator. So what we're going to type in is y1 is equal to d dx of ln of x, and then when x is equal to x. So this is the key part right here, because instead of just looking at a number, we're going to look at all values of x. So on your calculator, you go to y equals, and then for y1, you're going to type in the nth derivative, and then ln of x, and then x for all x. And then you hit enter, and instead of hitting graph right away, I don't know what my window is like, so I push zoom 6, and that gives me my standard window. And so what this actually did is it actually graphed the derivative of ln of x for me. This is a nice way to visually see your graph if you don't know what it looks like. And so here we have, this is ln of x. So this is y is equal to ln of x. And then when I graph the derivative, it looked like this. And it makes sense because right here, the tangent line is very large positive. And as you move further, it becomes smaller and closer to 0. And so it makes sense that the graph of my derivative starts very large and then ends up very small as you move across the x values.